Introduction. Tropical cyclone, TC, is one of the most serious natural disasters in the world. Satellite remote sensing technology can not only observe the whole situation but also the structural characteristics and center information of a TC. It is the current main method of the TC center location. Dvorak technique, DT, is widely used to TC center location. DT, which was proposed by in the 1970s, was the most important method for TC analysis in the world. Nowadays, based on the DT, advanced Dvorak technologies were developed to determine the TC center location. Li et al. Put forward a new artificial intelligence algorithm for the ITC center location. First, the image segmentation technique was used to extract the TC cloud features. And then, the mathematic morphology opening operation and the filling operation are used to obtain the contour of the TCI. The gravity calculation method is applied to locate the TC center. Comparing the data to the Central Meteorological Observatory of China, the experimental results show that the deviation is smaller. Li et al. Proposed an improved genetic algorithm to determine the TC center location. The theoretical analysis and experimental results show that this method is reasonable and effective. Zhang et al. Combined pattern matching with the vector field analysis to determine the TC center position. The proposed method is very efficient for the TCs, which have clear spiral structure. Fan et al. Used 85 GHz vertical polarization channels in specail sensor microwave/imager, SSM/I, for TC center location. According to the distributed characteristics of brightness and temperature, the TC of its band is analyzed and classified. The average gap of the best route in the test results of TC is smaller. Wei et al. Presented a novel spiral band model to automatically locate the TC center. And particle swarm optimization was used to optimize the model parameters. Experimental results show that this model can achieve the best average error in both latitude and longitude in comparison with the best tracked data. Zhang et al. Proposed a novel intelligent automatic system framework, which was based on the image process technology to locate the TC center. According to the symmetry shape and spiral movement feature of TC, a rotation matching methodology is used to catch the track of TC. Compared with the data of Shanghai Meteorology Center, experimental results show that this system is efficient and the performance errors are acceptable for practical applications. Zhang et al. Established the TC forecast service production system based on Geographic Information System, GIS, technology and realized the function construction. It had met the requirements of the TC Center forecast service production in the Central Meteorological Observatory. Recently, some researchers used deviation angle variance and pattern matching algorithm for TC center detection. Although there are some advantages in the above methods, some defects are existing. The subjectivity of DT is stronger, and the degree of automation is limited. The location effect for the smaller intensity cyclone is poorer. The method based on mathematical morphology is suitable for tropical cyclone whose morphology characteristic can be identified easily. If it is applied to the weak or atypical morphology cyclone, a big deviation will be resulted. Intelligent learning method requires a lot of experimental data and experience accumulation. It is suitable for recognizing the particular structures. Wind field analysis method is applicable to locate the tropical cyclone center, which is weak and whose circulation center is not clear. When the intensity level of tropical cyclone is higher, the center location is not accurate because it is easily affected by the resolution and heavy rain. The temperature/humidity structure retrieval method is also only applied to locate the tropical cyclone center whose intensity is strong. The tempo-spatial movement matching method applied movement information of adjacent satellite images to determine the TC center position. But the computation burden of the method is large. Generally, center location for ITCs has good results. But it is not very satisfying for non-ITCs due to some reasons. Therefore, it is very important to improve the accuracy of automatic TC center location. Here, we extract the inner core region from an infrared satellite image, which contains a TC initially. Then, according to the characteristic of the position of TC center, which is the intersection of the ambient airflow and the different textures between the inner core region and other cloud area, we determine the TC center further. and the texture is uniform and smooth in the inner core region. The gray values of the inner core region are higher than those which are on the edge of the TC. So, we calculate the fractal dimension and 3s order statistical parameters of a gray gradient co-occurrence matrix to determine the inner core region of the TC. Then, according to the gradient information of the inner core region, the center location of the TC is determined.